Hello students, welcome back to another video on data structures. In this session, we are going to cover the lab program 4. The problem solved in this video is write a program to insert the elements 61, 16, 8 and 27 into a singly linked list and delete 8, 61, 27 from the list. Display your list after each insertion and deletion operation. The general approach to solve this problem is, first we create a list with the given elements and we perform the delete operation. The first element to be deleted is 8, which is present at the middle of the list, 61 which is present at the beginning of the list, and the third element to be deleted is 27 which is present at the last position. And after every operation we need to update the list and display the list. This is a linked list with the given 4 elements. Before moving to program in code blocks, let us understand the steps and the logic. The linked list we create with the 4 elements. 61 is the first node value, 16, 8 and 27. The last node's link value is null because it is the last element in the linked list. We can create the linked list using the structure in C programming language. New node, we create one more variable which is also of type struct node. Its value is null initially. After creating the structure for the list, we assign the size for the new node using malloc function. And its data part we update with the value 61 and its link value is null. This code we repeat for inserting the remaining 3 nodes as well. Now, how do we perform the delete operation in linked list? Now the first element to be deleted is the value 8. We can observe the diagrammatical representation of this linked list. 8 is present in the middle of the linked list. If we observe the position values of each node, the position of the node which is having the value 8 is the position 3. We need to delete this node. Directly we cannot delete. As it is a linear linked list, we need to traverse starting from the head pointer till we reach to the required position and then we need to delete. For this, additionally we use 2 pointers. One is temp, another is ptr, which takes the same value as head. Now temp is pointing to the first node. Currently it is in the position 1. It is pointing to the first node in the list. We need to traverse the list till we reach to the position 3. We increment the value of temp. Temp is equal to temp's link. Now the link value is temp was pointing to the first node. Its link value is 2002. Now it will move to the next node by incrementing its link value. Now temp is pointing to the second node. We repeat the same step. Now temp is pointing to the third node. We need to break the link between the second node and the fourth node, which is the third node link. We need to delete the third node from the list. The simple code we use, ptr's link is equal to temp's link. Now currently ptr's link is value 2004. The address of the third node it is storing. Instead of storing third node address, ptr will be updated with the temp's link. Temp's link is nothing but the value 2006, which is the address of the last node. Now 2004 will be replaced with the value 2006 so that we can connect directly the second node to the last node. This is how we break the link of the third node from the list. Now you can observe the third node has been deleted. It is stored in the temp value. Now ptr's link value is null as it is the last node reference. Now we use a function free which frees the memory which is allocated to the third node which we have deleted. This is how we delete the element which is present at the middle of the linked list. We are deleting the value 61. 61 is the first node in the list. Head is pointing to the first node always. Now temp is equal to head. We create another pointer temp which takes the value of head. Now temp is also pointing to the first node. as head is pointing to the first node, instead of pointing to the first node, we update the value of the head pointer. The head is equal to head's link. Head's link is the value of the address which the first node stores. It is 2002. Now the head pointer is pointing to the second node in the linked list. Now temp is pointing to the first node. We are going to delete the temp from the linked list. Now we are remaining with the two elements. Now the last element to be deleted from the list is 27, which is present at the last position. This is the second node in the list. We use two pointers, temp and ptr, which is pointing to first node currently because head value is assigned to temp and ptr. Head is pointing to the first node whose address is 2002. We traverse list using temp pointer. Temp is equal to temp's link. Now temp is pointing to the last node of the linked list. We can free the temp by using free function. It releases the memory which is allocated to that node. In the next step, you can observe the ptr's link is equal to null. We are having only one node in the linked list. We have deleted the three different nodes from the linked list. This is how we perform the linked list operations. Let us understand the C code for these operations. Let us move to code blocks. Let us understand the C code. Here we use a structure, struct node. Struct is a keyword followed by the structure name. The structure name is node, which has two members. One is info of type int, which stores the value which we are going to store in the list. And another link is a pointer, which is of type struct node. Here the link pointer is pointing to a node in list. And we have created another pointer header of type struct node, which initially has the value null. So this refers to the starting node in the linked list. These are the initial global declaration in C program. We have one function display, which is used to retrieve the values from the linked list. And then we have one more function which performs an insert operation, insert list, which has a parameter int item. And we have another function delete list, which performs the delete operation in linked list. Let us understand the flow from main function. In main, we have declared a variable item. This item variable refers to the value during our insert and delete operation in the program. We have four insert list function call in the sequence which follows the order in which we are inserting the elements. First we call the insert list function by passing the parameter 61 and then 16, 8 and 27. This is the insert list function which takes the parameter item. Item, for the first time when we call this function, the value is 61. Declared two additional pointers, new node and temp pointers of type struct node. When we perform insert or delete operation in linked list, we use a temp pointer to traverse. New node, which refers to a node which takes the value item to insert. Malloc is a function which is used to allocate memory dynamically at the runtime whenever we create a new node. Here the new node will be assigned with the memory which is of size of struct node. Here the struct node refers to the size of the structure, which refers to two data members of the structure. The malloc function is used to allocate memory dynamically to the new node which we create. The new node's info is the value which takes the key value, that is item. For the first time the value is 61. New node's link is equal to null. That is the first node which we are creating, its link value is always equal to null. We have an if condition. If header is equal to null means we have created only the structure, still the list is empty. We are inserting the new node to the list. That address value should be stored in header. Now the new node reference will be copied to header node. If the header is not equal to null, that means we have the node values in the linked list, the statements under else will be executed. Under else we have temp is equal to header because To insert the value, we need to traverse the list. For that, we use temp pointer. Temp is assigned with header because header always points to the first node in the linked list. Temp always start the traversal from the first node. The while condition we use to traverse the list using the temp pointer till it reaches to end of the list. Once we reach to the end of the list, the temp's link will be assigned with the new node's address. This insert list function we use to insert all the given elements. Let us build and execute this program. First, let us compile the program using the option build. This is the output after inserting the 4 elements into linked list. For the first time, we have inserted 61, then 16, 8, followed by 27. The first node in the linked list is 61, which is pointing to the next node, and the last node is 27 and its link value is null. This is the insert operation in linked list. Now, according to the given problem statement, we have to delete the 3 elements from the list. This is the delete function. When we call the delete list function by passing the parameter value as 8, that 8 value is assigned to the variable item. We have defined the 2 pointers, one is temp and previous. The temp pointer is used to traverse the list. Previous pointer always points to the previous node of temp. We have an if condition. If temp is not equal to null and temp's info is equal to item. The statements under this if condition will be executed if the element which we are deleting is at the first position in the list. Where header is pointing to the first node, we are deleting the reference of the header node. So the statements under this if condition is the temp's link is always the second node's address in the list. That second node's address we are assigning to header node so that the header node will point to the second node instead of the first node. Temp is pointing to the first node. We are going to use free function to free the memory. We have a while condition while temp is not equal to null and temp's info is not equal to item. That means if the node which we are deleting is not the first one, the statement under while condition will be executed. So we assign the temp pointer value, which is the reference to the first node, to a previous pointer. So every time when we traverse the list using temp pointer, the previous pointer also will be incremented by its address value, which points to the previous node of the temp. And we traverse using the statement temp is equal to temp's link. We have an if condition, temp is equal to null. This condition indicates the temp reaches to the last node, its value is null. The key element which we are searching to delete doesn't present in the list. We have the 2 statements. If we find the position of the node which we are deleting, we use the statement previous link is equal to temp's link. So we unlink the node from the list which we are deleting and we use the free function to free the memory held by temp pointer. After every operation, we print a statement using printf function, the element which we have deleted from the list. This is the delete list function, which has mainly 3 conditions. If the element is at the first position, or if the element present at some position in the list, or it is present at the last position. This is the delete list operation, which performs the delete operation based on the position of the value which we are deleting from the list. Let us check the delete operation by executing this program. Let us compile the program again. Check the output. Now this is the output. After inserting all the 4 elements, we perform 3 delete operations. The first element deleted is 8 from the list and the second element we have deleted is 61 and then 27. So finally we have only one element in the list, that is 16. This is the output of this program. Thank you for watching.